A little bit about how to do this. Let me explain about how to do this experiment a little bit. You're going to find somebody's mass, et cetera, and then you're going to find the acceleration due to gravity. Just use the internet to find that. You'll find there's some websites that talk about the acceleration of gravity is different in different parts of the world. It has to do with a variety of factors. One of is the altitude. Of course, if you're further up, that would be a difference. But also your proximity to the equator makes a difference, because the Earth, as it turns out, is not 100% spherical. So see if you can do an internet search and find that. I probably just answered question 2. Yeah, listen to what I just said a minute ago. Where would you want to move to your weight? Because remember, weight and mass are not the same thing. Weight is in newtons. That's just F equals m times the acceleration of gravity where you're at. And so since if the gravity is higher in a certain locale on the Earth, then your weight measured in newtons will be higher. All right, then use some research and find the person's weight on the surface of that astronomical object. So this is just kind of a research thing, kind of work in some pairs and groups, and I think you'll figure this out. You can get the rest of these. All right, I think you can kind of keep figuring this out and figure out how many G's. By the way, what does that mean? How many G's? If it's 9.8, you take 9.8 divided by 9.8. That's 1 G. If I've got, let's say it's, 20 meters per second squared at some planetary object like Neptune or something, you divide that by 9.8, that's roughly 10. That would be 2 G's, was how we would say that. I'm rounding it. But you want to do that with the things you have. Sometimes you'll have a half a G, or like I believe that the moon is 0.2 G's or something like that. You know what, on this part, I'm not sure this is important. I think you can skip this part right here.